For more than half a century, the Vehicle Assembly Building, or VAB, at NASA's Kennedy Space Center has been an iconic landmark in the pursuit of space exploration. It is hard to imagine now, but before the VAB, rockets used to be assembled outside in the elements at ground zero, right on the launch pad. But as rocket technology advanced and missions became more complex, it became clear that a more sophisticated approach was needed. And so in 1963, construction began on what would become a true titan of engineering. Standing 160 meters tall, the Vehicle Assembly Building is one of the largest single-story buildings in the world, with vast high bay doors that can rise almost 18 meters off the ground to let in natural light. It provides the perfect environment to assemble these marvels of engineering. But it is not just the size of the VAB that makes it such a remarkable feat of engineering. It is also the precision and complexity of its design that allows it to serve its function so effectively. The interior of the building is a labyrinth of catwalks, cranes, and other equipment that all work together to allow for the precise manipulation of massive rocket components. The building's 4 high bays are each equipped with 2 bridge cranes that can lift up to 295 metric tons. These cranes are controlled with such accuracy that they can place a component on a rocket stack to within a fraction of an inch of where it needs to be. And then there are the giant doors, which are designed to open and close with such precision that they can accommodate even the largest rockets that NASA has built. The whole system is controlled with such precision that the entire process of assembling a rocket can be carried out inside the VAB without any components having to be dropped or maneuvered awkwardly. This level of precision is essential because even the smallest mistake can have catastrophic consequences. So how did NASA pull it off? How did they manage to create a building that is not just large, but also precise enough to assemble some of the most complex machines ever built? The answer lies in the details. Every aspect of the VAB's design is geared towards precision, from the reinforced concrete floor that supports the weight of the heavy rocket components to the steel beams that form the building's skeleton. The building is also equipped with a variety of sensors and other equipment that constantly monitor its condition and provide feedback to the engineers. This allows them to make any necessary adjustments and ensure that the building remains safe and stable at all times. But perhaps the most important aspect of the VAB's design is the way in which it was built. The building was constructed using a variety of innovative techniques that allowed it to be built quickly and accurately. For example, the foundation for the VAB was built using a technique known as deep cement mixing, which allowed the building to be constructed on the soft, sandy soil of Florida's Space Coast. This innovation allowed the VAB to be built on time and on budget, which was crucial given the tight schedule and constraints of the space program. Today, the Vehicle Assembly Building stands as a testament to the ingenuity and determination of the engineers and construction workers who built it. It is a structure that was designed and built to withstand the rigors of space travel and to support the most complex rocket ever built. It is also a building that has stood the test of time, continuing to serve its function for more than 50 years. As NASA prepares for the next generation of space exploration, the VAB is sure to play an important role. Its ability to accommodate the largest and most complex rockets means that it will be able to handle the next generation of space vehicles, as well as those of the future. The Vehicle Assembly Building is more than just a structure made of concrete and steel. It is a symbol of human ingenuity and the relentless drive to explore the unknown. It is a structure that was built to push the boundaries of what is possible, and it continues to do so today. In the early days of the US space program, the rockets were small and simple enough to be assembled on the launch pad itself. But as the program grew, so did the rockets, and it became clear that a different approach was needed. The solution was the Vehicle Assembly Building, or VAB, a massive structure that would provide the controlled environment needed to assemble the largest and most complex rockets ever built. The VAB was not the only option considered. Other possibilities included assembling the rockets in a trench or in a cave, but these options were ultimately rejected as not being feasible. A trench would have been vulnerable to the elements, and a cave would have been too difficult to access. The chosen site for the VAB was a flat, sandy area near the existing launch facilities. But this presented its own set of challenges. The soil was too soft to support the weight of the rockets and the building itself, and so a new technique had to be developed to build the foundation. Deep cement mixing was the answer. This technique involved mixing cement with the existing sand to create a stable foundation for the building. But it was not without its challenges. The deep cement mixing process had never been used on such a large scale before, and there were concerns that it might not work. But the engineers were confident that it would hold, and they were right. The VAB has stood for over 50 years and is still going strong. It wasn't just the foundation that had to be carefully planned. The interior of the VAB is a marvel of engineering, with a series of catwalks, cranes, and other equipment that all work together to allow for the precise manipulation of massive rocket components. The 4 high bays are each equipped with 2 bridge cranes that can lift up to 295 metric tons. These cranes are controlled with such accuracy that they can place a component on a rocket stack to within a fraction of an inch of where it needs to be. The interior of the VAB is also designed to provide a clean and controlled environment for the assembly of rockets. The building is equipped with a variety of air filtration systems that help to keep the air free of dust and other contaminants that could damage sensitive components. The air conditioning system also helps to maintain a comfortable temperature inside the building, which is important for the workers who spend long hours inside assembling the rockets. One of the most impressive features of the VAB are its giant doors. The doors are designed to open and close with such precision that they can accommodate even the largest rockets that NASA has built. When the doors are opened, they rise up on giant tracks and can reach a height of almost 18 meters. This allows for the passage of the tallest rockets, including the Saturn V and the Space Launch System. The doors are also equipped with a variety of sensors that help to ensure that they move smoothly and safely. But the VAB isn't just about the building itself. It is also about the systems that connect it to the rest of the Space Center. The VAB is connected to the launch pads by a network of roads and railways that allow for the transport of rockets and other equipment. The most famous of these is the Crawlerway, a 40-meter wide road that connects the VAB to the launch pads. The Crawlerway is used to move the massive rocket and crawler transporter, a machine that is nearly as large as the rockets themselves. The crawler transporter is responsible for carrying the rockets from the VAB to the launch pad, and it is a truly impressive piece of engineering. The machine consists of 2 connected 20-meter wide transporters, each powered by a diesel engine. The transporters are connected by a central platform that allows them to be steered and controlled remotely. The crawler transporter moves at a speed of less than 1 kilometer per hour, making the journey to the launch pad a slow but steady process. Despite its size and complexity, the VAB and the surrounding infrastructure have proven to be remarkably reliable. The building has never failed to open its doors for a rocket launch, and the crawler transporter has never broken down on its way to the launch pad. This reliability is a testament to the careful planning and construction that went into the VAB and its surrounding infrastructure. The Vehicle Assembly Building at NASA's Kennedy Space Center is a marvel of engineering and a symbol of human ingenuity. From its unique foundation to its massive doors and intricate crane system, every aspect of the VAB is designed to meet the unique challenges of assembling and launching rockets. As NASA prepares for the next generation of space exploration, the VAB is sure to continue playing an important role, allowing humans to push the boundaries of what is possible and explore the unknown.